Hello everybody, in this lesson I will introduce general solution in trig equations and I will deal with the example below. Trig equations do not need to be restricted to the interval x is an element 0 up to 360 degrees. Sketched below are the solutions to cos x is equal to 0,5 for the interval x is an element negative 720 up to positive 720 degrees. Now, there is more than one solution for cos x is equal to 0,5 in this interval. Now, that line that goes through 0,5 on the y. Now let's decide at which angle the y will be 0,5. This is what this is all about. Now if you look at this, when you slot into your calculator cos 60, you find the answer is 0,5. When you do cos 300, you will see the answer is 0,5. Cos 420, the y is 0,5. Cos 660, the answer 0,5. And then you can also do the same for negative angles. If you do cos minus 60, the answer is 0,5. Cos minus 300, the answer 0,5. Cos minus 420, the answer 0,5. And then cos minus 660, the answer 0,5. Now, all of this can be summarized as a trig equation. The general solution for cos x is equal to 0,5. And there's two situations. The first one is quadrant 1. Now where does that come from? Remember when we did this specific solution, when you go back to cos x is 0,5, remember we said we look at the sign there in front of the 0,5 and then we decided in which quadrant we are working. So the sign is positive, so we say where is cos positive? It's in the first quadrant. And then you write x is equal to 60. This is that reference angle, that acute reference angle we calculated. And then for the specific solution, you add plus k times 360, k element z. Now we turn the specific solution into a general solution. And then again, we will go back to the equation. Cos x is 0,5. We say, where is cos positive? It was the first quadrant and in the fourth quadrant. And then the specific solution would be x is 360 minus 60 degrees, because in the fourth quadrant the rule is 360 minus the acute angle. And now the general solution is exactly the specific solution. X is 360 minus 60, but then for general solution we add plus k times 360, k element z. Now if you substitute the values -2, -1, 0, 1 in k's place, you get all the values without sketching the graph. Now let's see. In quadrant 1, the general solution is x is 60 degrees plus k times 360, k element z. Now, when we substitute k is equal to 0 into that general solution, we get x is 60 plus 0 times 360, and then your solution is just 60, and that is at A. At C, when we substitute k is equal to 1 into the general solution, and there C, we say it's 60 plus 1, this is case value, 1 times 360, we get the solution 420 degrees. At F, when we substitute K is -1, we end with the solution X is minus 300 degrees. And at H, when we substitute K is -2, we end with the solution minus 660 degrees. And then, now where's the others? The 300, the positive 660, the minus 60, the minus 420. That is where quadrant 4 comes in. The general solution is X is 360 minus 60 plus K times 360 K element Z. Therefore, X is 300 degrees plus K times 360 K element Z. That is the general solution in the fourth quadrant. Now let's see. At B, when I substitute 0 into the general solution, I end with X is 300 degrees. At D, when I substitute in K's place 1, I get X is 660 degrees. At E, into the general solution, if I substitute K is -1, I end with minus 60. And at G, it's that one, when I substitute K is -2, I end with X is minus 420 degrees. Please note, for sin and cos, we use plus K times 360 degrees K element Z. And for tan, we use plus K times 180 degrees K element Z. This is because of the respective functions, period. Now let's look at our first example. The question is, find the general solution of. Now I just want to tell you that finding the general solution is in fact exactly the same process as finding the specific solution. It's just right at the end where you're going to add plus K times 360, or in this case K times 180 K element Z. Let me show you. Now we will find the solution to tan x plus 1,374 is equal to 0, and it walks across and we end with tan x is minus 1,374. Now we're going to find the acute angle or the reference angle with your calculator, and you will say shift tan, and then you ignore the minus and you only slot in 1,374 close bracket equals, and then your acute angle will be 53,95 degrees. Exactly the same process as finding the specific solution. That's lesson 1. Now you will go back to the sign here and you will say, where is tan negative? Tan is negative in the second and the fourth quadrant. Then quadrant 2, quadrant 4. Now you say, the angle that used to live there by tan is x. So on the left hand side, there's just an x. And then in quadrant 2, the solution is 180 degrees minus the acute angle. And that is the specific solution. And now with general solution, you add plus K times 180 K element Z. And then you can just solve your equation there. X is equal to 180 minus the acute angle, which is 53,95 plus K 180 degrees K element Z, and then your final answer for the general solution here in the second quadrant is X is 126,05 degrees plus k times 180 degrees, k element z. And then in the fourth quadrant, remember there was just a x at the tan, so on the left hand side there's just x, and then in the fourth quadrant it's the 360 minus the acute angle. Up to there it's just specific solution, and now for the general solution you only add plus k times 180 k element z. Now we can substitute the acute angle, therefore it's 360 degrees minus 53.95 degrees plus k times 180 k element z, and then your final answer, general solution in the fourth quadrant, will be x is 306.05 degrees plus k times 180 k element z. In the next lesson, I will do another practice example on trig equations general solution. Click on the video in the left hand corner to take you straight to the next lesson.